Hi, I'm Monica Dela Cruz, and I will be discussing how to plot flow rate versus time and delta versus time in terms of the reduction step. First, we have to define the necessary terms that will be used to make the plots. Ri is the flow rate of a particular species, and delta is the non-stoichiometry, which is how much oxygen that has been removed from the ceria relative to CEO2. This means that the quantities of the reactants are not integers. In this presentation, I will show how these two variables change with time. In order to find the flow rates versus time, I'll discuss the overall process of the experiment. The figure on the left shows a diagram of what the experiment looks like, while the figure on the right shows a schematic of how the process is run. Here we have a packed bed of ceria, and in order to control the temperature of the bed, an electric furnace will be used. There are two main steps, reduction and oxidation, but I'll only talk about reduction. Reduction is where you supply methane into the system, where it reacts with the metal oxide, and we get a mixture of gases out. There were no calculations regarding this plot. However, after pulling data from the figure that Professor Krensky provided to us, we now get this new plot that shows us the flow rate of each species versus time. During the reduction process, we start with a larger amounts of oxygen, which can be seen on the far left side of the graph. As time proceeds, you can see the oxygen content decrease while the products of the reaction increase, which is why this step is called reduction. To find delta versus T, the first step is to write the equation that describes the flow rate at which oxygen is released from the ceria in terms of how much oxygen is coming out of the system. This first step sums all the species containing oxygen, where the coefficients of each of the terms tells you how many oxygen atoms there are per molecule. For example, there is one oxygen atom per carbon monoxide molecule, two oxygen atoms per one carbon dioxide molecule, and one oxygen atom per one water molecule. The second step requires you to convert the flow rate into a molar quantity, where Rho reduction is the reduction rate from before, zeta is a conversion factor from milliliters to moles, and MCO2 is the molar mass of the metal oxide. After canceling out the necessary terms, you should end up with moles of oxygen per mole of ceria per second. The last step is to plot the number of moles versus time using the cumulative trapezoid function, where we get the figure on the right. From this plot, we can say that as time increases, delta also increases until a certain point where it reaches a steady flat line. We can interpret this to say that as delta increases, it gives more of the desired products.